This is Cooper Melgreen
Grant Halter.
And Jared Bernicky.
doing an analysis of Augustana admission data. So the first step of this project is to clean the data so we have a uniform data set that we can analyze.
Looking at the data, you can see that there are a lot of blank spaces, and then there are categorical variables and numerical variables and character variables that require cleaning to make the data set uniform for working with.
We decided to pick status to be our dependent variable, and status has 3 levels. DC, which means Augustana declined the student. TW, which means that Augustana accepted the student, but the student decided not to come. And ST, where the student was accepted and they decided to come to Augustana.
For our independent variables, we have state, which is the state where the applicant is from, their gender, per ethnic, which is non-Hispanic or Hispanic. We have race 1, which is a more specific classification for the applicant's race. We have the applicant's ACT score, their class percentage in high school. App rating is the strength of the application. DemInt is the student's demonstrated interest in Augustana, and Major 1 is the planned major of the student.
You can see here our new data set with the independent and dependent variables. There's still some work to be done on it though. We want status to end up as a binary variable, and then there are some blank values in the dependent data that we have to fill in. This is the function we're going to use to transform status. Anything equal to st we will code as a 1, and everything else we will code as a 0. At the bottom is the R code that we use to perform this transformation. Back in the data set, you can watch our transformation work its magic.
Here we have the same type of transformation as status, but in this case, the value of Illinois is set to 1, and everything else is set to 0. And again, here we have the code at the bottom. And here's our transformation at work.
There are still missing values. For the numeric variables, we will place the blank values with the mean.
Everything is starting to look a lot better. All that's left is to omit the rows that have blank values in the categorical variables. So we just omit everything in those rows and then collapse the data set back down. And just like that, we have a clean, uniform data set to analyze.
We could build the model on the whole data set, but instead we split it into training and test sets so we can verify that it is accurate. We use an 80-20 split for this partition.
Our model is a logistic regression model. This gives the log odds of enrolling in Augustana in terms of applicant state, ACT score, app rating, demonstrated interest, and major.
Mathematically, a logistic regression is a linear function of independent variables that minimizes the error. Once we have the model, we run a step function over it that removes the statistically insignificant variables. In our case, all the variables included were kept, so we created a new model that included interactions between these variables, but the step function removed their interactions.
Analyzing our logistic regression showed that it's actually a pretty good model. It correctly predicted 70% of the students who would or would not attend Augustana in the fall. Looking at sensitivity and specificity, which is the probability that a student who will attend is correctly identified and a student who will not attend is correctly identified respectively, shows that our model is also pretty good at this. Sensitivity equals 0.635 and specificity is 0.729 out of 1. Most important is our AUC value of 0.738. This shows how much of the data our model explains, and what AUC means will be explored in the next slide.
This is the ROC curve. Sensitivity is plotted on the y-axis, and 1 minus specificity is on the x-axis for various cutoff points. A perfect model would be a straight line across the top, with an area under the curve, or AUC, equal to 1. A worthless model would be a line with a slope of 1 and an AUC of 0.5. Our model, with an AUC equal to 0.738 for the test set, is a decent model.
Despite that, here are a few weaknesses.
The first weakness is that we only had 1 year of data. If we had had more years, it would have made a more accurate model. Secondly, all of our interactions were dropped with the step function. We know some of the other people who did a similar project kept the interactions. That might just have to do with the partition that we used, which brings us to a third weakness, which is that we only ran it on a single partition. More advanced statistics can be used to validate the model if you run it on multiple partitions.
Thank you.